Let's just run the whole thing back. There we go.
Thanks for.
Yeah.
Like sometimes. Okay, everyone. Thanks to everyone who came today. So today I'm just gonna go over some basic Python, and I have all the topics laid out here. So to create a variable in Python, you just give it a variable. You just give it a variable name. Here, I just make it x. You give it a you just give it a value. And in Python, there's no like the typing is dynamic. So here I can. Okay, so let's just print x. Okay, so you can actually change this type. So let's turn this into like x into a string. Let's just call it a print x. So you can see here that Python, like if you make it a integer at the beginning, you can change it to any other data type like a string. You can change it to like a dictionary. It doesn't really matter. This is like a different to Java where like once you declare a type, like you usually do int x equals something. And once you create x as an int, you can't set it to anything else. Okay. There's some few rules like you can't put like there's a few like naming conventions. You can't do like put like weird stuff in here, but as long as you have something sensible, the variable name should work. Okay, so how do you create a function in Python? You just do def, and then just give it a function name. Let's just do square. Let's just square the element that we pass through. And let's try this thing out. Square 5, 4. Okay, so you can see here. Okay, so what happens if we want to create a void function? We can just not return anything. Well, technically it returns none, but. So what happens if we want to create a function on one line? So just use a Lambda function. Okay, so here, these are the arguments. So here you put your arguments, and then here is what you'd return. So let's just try this out. So let's just give it like f. Oops. Okay. And Python is also functional, as in that you can pass in functions to another function. So let's just create another function called def eval f for evaluate the function, and let's just f, and then let's get a value, so x. So return f x. So we can eval, just pass in the function we created earlier, f, and let's put it like 8. Oops. There. Okay. And the reason we use Lambda functions is because like sometimes, because it like helps save space. Like this is kind of awkward. Like say you have like something that doesn't really do much. Like picking 2 lines is kind of awkward. And it's also nice to pass in like functions in like 1 line. So you have a map. Or like sometimes functions like you just pass in like here, let's just do something. Okay, so sorted. Okay, so let's just create a dictionary. We're gonna go over dictionaries later. So d equals 1 2 7 5 7 5 6 3 2 6. And let's say we want to sort this dictionary by the value. So and so what we can do is just pass in a lambda x, and then we want to get the item at the first, so that it's a 0. So 0 would be the key, and 1 would be the value. So let's see this. Oops, I forgot to put the key. And you can see here, it is sorted by the value here. Okay, so control statements. So if it's usually if and else's. So let's just create like an x equals 10. So if x is greater than 5, let's just print x. Else, no, print x plus 100. It's quite simple. I mean, it's not really very interesting. Okay, so this is a little more interesting. So lists and dictionary comprehension. So in Python, to create a list, you just use square brackets. And let's just look at this. And then you can append something. So if you want to add something to it, you can just append. And let's just look at it again. Okay. So what happens if we wanted to score everything in here? So what we could do is, so first we have here. Actually, let's go over what a for loop is. Okay, in Python, to go over for loop, so for I in range 10, that's how you iterate from 0 to 9. Let's just see. You can also, for I in any type of like collection, so let's just do for I in like 5, 6, 1, 3, 4. And you can see that also works. And that's how you do for loop in. This is basically for each loop here. And earlier, okay, so let's create a list. Okay, so we basically do for loop. So for is very similar to like for loop syntax. So we can call it whatever. So let's just do e for element in ls. So what do we want from this e? So we just want, let's just do like just a plain. Let's call this d. Let's just call it, let's just put list. You can see it's the same now. So what happens if we want to square all the elements? So we apply all the, so here, since this is sort of like a, so whatever's here gets added to the list. So here we're iterating through all the elements in this list here, in this ls list. And then so we iterate it, and then we get this item, and then we can do whatever we want to it. And since we just left it vanilla here, we just got the same list back. So what happens if we want to square it? So we just apply some function to it, like squaring it. And this is how you square in Python. You just do like multiplication sign twice. Let's look at D now. You can see here it's just squared everything. And you can also do this with very similar for dictionaries. So let's just say, let's just make a dict, DC. And let's just make it the value and then the value plus 1. So to create a dictionary in Python, you use curly brackets, and then it's a various key value pairs. So let's just get everything from, let's just use every element in ls, the list, as the key, and then the value of ls for a key plus 1 to be the value. So let's see what that looks like. So let's just leave that. So let's just leave this side blank. Let's go. So for e in ls. Okay, so what do we do here? So first we specify the key e, and then let's just do e plus 1. And then let's look at these. Okay, so and then how do we access stuff from a dictionary? So we access it by putting like some like the key. So let's just let's see what we do when we put in like 4 for the key. We get 5 as we expected. Okay. So what happens if we wanted to like, let's just square everything in this DC thing. So DC2 for DC squared. Okay, so to iterate over a dictionary, we'd usually call the items on the dictionary. So let's just for a key value in DC. Let's just look at what DC looks like. DC items. get DC, then DC dot x. So let's. So you can see here just like key value pairs here, and it's in like a dictionary. And when you do dot items, what happens is it turns it into a list of tuples where the first element here is the key and this is the value. So this is really nice when we want to iterate over a dictionary. Let's just move that. So DC squared. So what we do is we want to square the key and use that, and then we want to square the value. So let's just print DC and print DC squared. Oh, we have some shit. I didn't look at the questions. Is there a return for? Oh, that's a good question. So Edward answered it, but you can create. So okay, so you don't have to return anything. Like it automatically returns when you use the lambda. Here, let's go back to it. It like yeah, let's create a lambda that just prints whatever you give it. So let's just override the old value. So lambda x print Bob. So oops, let's print the x. So f of 3. Let's just comment that. So you can see here it still works, but what it does is it prints none. I mean, it returns none. So let's just print what f of 3 looks like. Get a none object. From this is a since it doesn't return anything, we get a none object back. But you can definitely use lambdas to do like weird stuff. Okay. So, yeah, and so the return is implied, but you like if you just do something in there and you don't care about returning anything, it'll just automatically return 1 unless you're the function you call a function that returns something. And you can see here. Okay, so okay, let's go back to the list in dictionary comprehension. You can see here squared. Yeah. Yes. Okay. And that's how you do dictionary list comprehension. Okay, let's go over classes. Okay, so so what's the point? We have these functions and we have these variables. So what is the point of classes? Well, the point of classes is to be able to organize variables and functions into one coherent thing. So say we want to represent something like a human. Like, can a singular function define a human? Like, well, if the person is pretty basic, probably, but humans tend to be quite complicated beings. And they can do various things like eat, say something, earn money. There's a lot of fun. Okay, so let's just create a person. So person, last person. Actually, let's do dog instead because I'm gonna extend. I'm gonna show. So okay, so def bark, print bark. Oh yeah, you have to press itself. Okay, so what? Okay, so okay, so for those who know programming, init is basically the constructors. So let's just create self.legs equals 4 and def print legs. So let's create a dog. So this might not make sense for some people right now, but let's just. Okay, so okay, so you need, when you're using objects, every time you create a function, you always have to pass in self, because what it basically is doing is it's passing itself every time it calls a function. So just think of it like this. So like dog.bark, and then you pass in the dog object. And well, Python automatically does it, and it automatically takes up the first argument space, so we don't actually have to pass it in itself. And the reason this is valuable is because whenever we store a variable such as this legs to a dog object, we can use it. We can access it using self dot. So this is like so this is very similar to dog.legs. So say we're using this dog. However, we might not exactly know what we're gonna call this dog, so we just use self, so it's universal across all instances of a class. And an instance of a class is basically an object. So this is a class, and this dog here with the lowercase d is the object. And this is basically it. And the terminology is this dog object is instance of this dog class. Okay, hopefully that makes sense. Yes, it's very similar to this, except like it's even more explicit, because in Java, this keyword isn't necessary sometimes. Like most of the time it's not necessary, but in Python, it's basically this, but you're forced to use it whenever you want to use anything that pertains to the object. Great. Okay. So what happens if we want to create what happens if we want to create another dog that so I want to create a more specialized dog. I want to make a canine. Canine is how you spell it? Doesn't matter. So let's say it has an attack criminal, and then self, and then let's just criminal name, and it will like print. It will, so it doesn't actually, it won't actually attack the person but let's just have it just say it does it. The dog just creates an empty promise. Okay, so wait, so here let's go over what f does. So okay, so obviously we have like an x equals 5, and we have like a string. So ASDF. Okay. What happens if we want to use the x in here? So let's just try putting x there. It doesn't do anything. I want the 5 to show up here because x is equal to 5. Let's just put it here. I've seen some stuff like this, so let's just try this. Like in another language. Oh, it's still not working. So what we need to do is put an f in here, and what that does is it automatically tells the string to use formatting. So that anything in these curly brackets are interpreted as code, like code from before, like this x. Okay, so let's run it again. And that is exactly what we wanted. Okay, so that's basically what the f is. That sounds kind of funny, right? Like what the f is. Okay, whatever. Okay, so wait, we need to make. Okay, so what happens if we want this to be dog, but we want to have? So let's just. So what we can do is extend that old dog class. So okay, so let's create another dog. Dog. Let's just comment this stuff out. And to comment out in Python, what it does is it doesn't execute this code. So you do control /, and that's how you comment stuff out. And then you uncomment it using, when you have commented code, you just do the same command over commented code. Okay, so let's create a K9. And can we, okay, actually, here, let me just do that for a second. So can we bark? Can this K9 bark? Nope. So let's just put that back. Oops. Let's put that back, and let's see what, can we now bark? Now we can bark because this is both a dog and a canine. Well, a dog is a canine. It is a dog because here we extended it. So what we do is we get all the stuff from here. Okay, so how many legs does it have? So let's just print dog.legs. This canine's, how many legs does it have? has 4 legs. So we can not only access the functions, we can also access the fields. And these are called fields, the variables that you store inside an object. They're like specifically to an object using self-dot. That's called. Okay. Okay, so what happens if we have 2 dogs? So let's just create 2 dogs. So D1 equals dog D1 equals dog and D2 equals K9. So let's just put these in a list. So dogs equal D1, D2. Oh, it's spelled K9? Oh, shoot. Oh, it's too late because they, no, I'm just kidding. They spell it K with a 9, like the number 9, but then they spell it K, whatever. Okay, so so this is an example of polymorphism. So what happens if you wanted to, so we have a dog here, we have a K9 here. And let's iterate over dogs. For dog, if you remember it earlier, to iterate a collection, you just like for something, some variable name. It can be dog, it can be ASDF, like R. You can call this anything. So let's just do dog. For dog in, then we have to specify the exact collection's name. So let's copy that over and then let's just have this dog print bark. Let's just have it bark. Okay, that wasn't very interesting, but you can see here, well, we have 2 different, like slightly different objects. This is a dog, and this is a dog that's also a canine. However, because this extends a dog, we can ensure that this bark method is within here. So what happens if okay, so that was a very interesting. Like they both bark. So what can we do about it? What happens if we want the canine to do something else? So we can do def, and then let's just copy this exact thing over, just to make sure we have the exact thing, and print Benghazi. I'm just kidding. What? I don't know what canine sounds like. Well, okay, whatever. And you can hear this method is overridden. Like you have to make, so in Java you can usually have like a override. I'm pretty sure it's not. In Python you have to like import some weird stuff before you have to import some weird packages to have override. But okay, so if we just call the bark2, it doesn't work. So make sure you have the exact same method names to like override something. Okay, so hopefully okay, so that's most of Python. That was in 30 minutes. Wow. Programming sure is easy. No, I'm just kidding. It's not actually that easy. Okay, so let's go over pandas. Okay, so how do you import? Okay, so in Python, to import an external library, what you want to do is first pip install. And so how do we okay, so pandas. Let's just pandas install. You can usually just look at it because like sometimes like scikit-learn, it's weird. Like scikit-learn install. It's what? You do pip install scikit-learn, but then you import sklearn. So it can be kind of weird sometimes. But most of the times the package name is usually the same as the way you pip install. So I can't. Whatever. Let's just. I know it's pandas, so let's just do pandas. I already installed it, so it doesn't actually do anything. And if it requires any other packages, what it does is it downloads them as well. So it required NumPy, it required all these other packages, and it automatically downloads whatever you need. But when you're using Google Colab, a lot of data science libraries are, it already comes with data science libraries. So, okay, so let's just import it. Import pandas. Okay, so let's just do pandas.dataframe. Okay, that wasn't very interesting. Okay, let's print this. Let's put something in here. Okay. What happened? Okay, so, oh my God, I'm so lazy. I'm a programmer. well, my fingers are gonna get real tired. So what if I don't want to type out this whole dang pandas thing? So what we can do is import it as something else. So import pandas as PD. And this, oh wait, I already imported it. Okay, so if you're running this on like a .py file, this wouldn't actually work because you have to use PD. But in Colab, when you run something, it automatically gets saved. You can see here, like I run this X. Well, like this is because I'm using Jupyter Notebook. Okay, so how do we read something? Okay, so this is what a data frame looks like. So let's just create it like some random data frame. So I'm passing a dictionary, and the key is the name of the column, and these are the element values. So let's just do something like this. And it's just basically table data. And make sure you have like the same number of elements in each column, or else we'll get mad at you. So df equals, let's look at df. Okay, that was not very interesting. Okay, so what can we represent this type of data? Can we pick stock data and represent in this type of format? Well, yes, you can. So what you do is, okay, so let's go to my GitHub. You put on GitHub, you upload the file to like some repo. I call it file host because I put a bunch of random file stuff here. And let's take this data, the stock data. And if you're using GitHub, you have to do .raw, just so you get the raw file, because like it might not work. Okay, and let's see what this df looks like. Oh my, that's too much information. I only want the first 5 columns. So to get the first 5 things, you do .head. Because it's the, and you can specify, so what happens if I want more data? You just increase the, okay. Now I have 6 rows. So you just, what happens if I want to get the last stuff? Oops, tail, head and tail. It's quite intuitive, okay. And so you can see here. Okay, so for those who aren't familiar with open, high, low, close, last, think of last as close. So, so if you, okay, so let's just APL price. Okay, so here you can see this is the open, and this is also the highest price. So this would be the O and the H, this value here. Here is the low. And when the market close, okay, so open is like when the market opens, and it opens at 9:30 EST. And here's the value that it closes at. So you can see here that the price of a stock doesn't stay the same over the same day. That way, that's actually crazy. It went down 2.65%. That's actually a lot. Oh, whatever. So this is the low. So what happens is it turns it into like a so with open, high, low, close, so instead of representing all these individual data points, you just do the open, high, low, close to like make the data more compact. And we have it here. Here, I'm just gonna call it here. 1 second. Never mind. Whatever. Let's just do it like this. Okay, so how do we index? How do we slice? What happens if we want to get the like 10th to the 20th element? .iloc. We have to call .iloc, and that stands for integer locating, I think. And so we get the 10th and the 20th. Okay. What happens if we want to? What happens if we don't want to use numeric indexing? So let's change the index. So df equals df.set index, and let's just copy this, and that'll replace. So right now this is the index, like this. Okay, so let's just set that as the index. Oops. Oh shoot. Yeah, let's call this df2. And now the time is in the index. And so instead, when we want to access based on something that is not based on integer location, you can do .loc, and then we want to pass in one of these indices. Okay, let's just copy that exactly. And you can see here we get one row of data. Okay, so what happens if we want to access a column instead? So df open. Nice. And what happens if we want to access last? Nice. These are here. Let's see what the type is here. So the columns are in series. Okay, what happens if we want to keep it as a data frame? Okay, so series have like different very similar to. Okay, so what happens if we want to keep this in different? Well, you just pass in it as a list. So here. Now this is still data frame. Okay, so just to prove it, I'm just to make it like more clear that we're passing in a list to this argument. And so what we could do now is, what happens if we want multiple columns? We don't want all that other stuff. Let's just do last, open, and volume. And you can see here, this is how we can like slice an index to get certain things. Okay, so what are some useful things? So one thing that people usually do is PCD change, and that's a percent change. Oh yeah, we have here. What happens if we want to delete a column? Because we want to delete. Okay, let's just delete it. We don't want this time column, so let's just delete it. So let's create df2 equals df dot drop. Then we specify whatever we want to delete. Okay, so and since we want to drop it as a column instead of like the row, because 0 goes up and down, and x is 0 is up and down, which is the rows, and x equals 1 is column to column. And so we want to drop the time column, so let's just specify that as x is equal 1. Let's get to .pcd change, and we get the percentage change. So .hist. Let's turn this into a histogram. Wait, no. Let's just choose one of the things. Like, let's just make last. And why is this helpful? Is because you can see here, like, let's just plot last. Last dot plot. You can see here it goes up over time. However, I don't know why. However, if you fraction, okay, now it doesn't go up over time. And this is one method of making data more stationary. And stationary means that the mean and the variance stays relatively constant over time. And the reason you want that is because like some models, like auto-regressive integrated moving average model, or aka the ARIMA model, requires stationary data. And this looks a lot more stationary than this, because here, look at the mean here. It's around here, right? Then the mean here is around here. The mean here is around here. The mean here is around here. So you can see that the mean is constantly increasing. But here, like the mean, it stays relatively the same. Okay, what's another way to like, here, another way to do is logarithmic differences. So let's just, okay, this is not too important. Okay, so numpy.log. numpy.log.diff. And this is another way to make the data more stationary. That's out of the scope for today. This workshop, so let's just ignore that. Okay, so NumPy is great for representing matrix. So let's make a 2x2 matrix. So I already imported NumPy earlier. Okay, so NumPy.array. Let's just create a 2x2 array with 1, 2, 3, 4. So 1, 2. So that's my first row, and then 3, 4. And if it helps anyone, think of it like that. Now let's see what it looks like. You can see here it's a 2x2 matrix. And so how do we? Okay, so let's just store this data. How do you slice this thing up? So what happens if we want to get the first element at the first element at the column and the first element at the row? And it is 1 here. And it, okay, so what happens if we want to get just, this also works, I think. Yep. What happens if we want to get the first row? We just do that. We just go down. Okay, so if you think about it here, let's you can see here. So this is the 0. So as we go here, so this row is at the 0th index on the first 0th axis, and this is the first the 1th index along the 0 axis, and this column, this 1 and 3, is the 0th index on the first axis. Okay, yeah. And so here you do it by the order of the axis. Okay, so what happens if we want all the elements in the first column, but we want the first, we want everything in the row, and okay, you can see here it's 1. We want everything in the column at the 0th row. No, we want everything. We want everything in the column at the 0th index. Okay. And fun fact, Pandas is actually built upon. Oh shoot. Pandas is actually built on NumPy. So what we have the df2. Let's just top values. Let's just look at that. And this is a NumPy array. This is a NumPy array. So the underlying representation for a lot of these Panda data tables is using NumPy. And the reason we use NumPy is it's great for matrix operations. So let's just say, let's just create data2 equals 1, 2, 5, 6. If you want to, okay, so we can actually, okay, let's just multiply, let's just do matrix operation. Okay, so, here. You can see here, so 3 times 5 is 15. Okay, so you may like, wait, this isn't matrix. This isn't matrix multiplication. Well, yeah, it's not exactly matrix it's multiplication, just not exactly matrix multiplication. So what happens with this type of multiplication is that this value and this value multiplied it, and we put it here. This 3 and this 5 are multiplied together, give 15, and then it's put here. So what happens if we want true matrix multiplication? Well, we can use NumPy. So numpy.linalg.matmul. What? I'm pretty sure it's data2. Sure, I can't. What is this?
It's just numpy.matmul.
Oh, thank you. And we can see here it looks different, and this is the real matrix multiplication. And that's basically it. Okay. That was 43 minutes. That's quick. Okay, so if you have, thanks for everyone who came today. If you have any questions, please leave them down in the comments, or you can also DM me through my email or Facebook or any of my socials. Hopefully you guys learned something, and that'll be it for today's workshop.